for problem 35 reads, basketball player Daryl Griffith. I have no clue what team he's on, so I'm not a sports fan. But sports fans, you'll know who Daryl Griffith is. He is on record for attaining a standing vertical jump of 1.2 meters or 4 feet. This means he moved upward 1.2 meters after his feet left the floor. Griffith weighed 890 newtons or 200 pounds. What was his speed as he left the floor? So this is kinematics, V naught VADT. Our initial velocity is what we're looking for. Final velocity is 0 because when he reaches the top of his jump, he's not going to be moving. Acceleration's gravity, which is negative 9.81, and he moves 1.2 meters. We don't need the time. So we can use our v squared equals v naught squared plus 2ad, my favorite kinematic equation. So the square root of negative 2ad will equal our v naught. Negative 2 times, well, a is negative 9.81, d is 1.2, so square root of negative 2 times negative 9.81 times 1.2 equals the initial velocity, which is 4.85 meters per second. Yes, I used a calculator. Part B reads, if the time of the part of the jump before his feet left the ground was 0.3 seconds, that means over the course of 0.3 seconds when he's applying his force for his jump, what was his average acceleration, magnitude and direction? Well, it's going to be up, so that's your direction, while he pushed against the floor. So our net force is equal to mass times acceleration. The force over this time, the net force, will be his impulse, his change in momentum, divided by the time. The change in momentum is going to be his mass times his initial velocity we just found. So his mass times his initial velocity divided by the time will equal his mass times acceleration. His mass doesn't matter in this time. So initial velocity divided by time will equal acceleration. So 4.85 divided by 0.3 equals acceleration, which is 16.7 meters per second squared. Part C says to draw a free body diagram in terms of the forces in the diagram. What is the net force on him? Use Newton's laws as a result of part B to calculate the average force he applied to the ground. That is going to be equal to the force pushing up. So, free body diagram, the force of his jump is pushing him up, or that's the ground pushing on him. It's kind of a force normal, really. Force of gravity is his weight, which is 890 newtons. So force of the jump minus the force of gravity equals his mass times his acceleration. His mass is 890 over 9.81, using, force of gravity equals mass times g. So the force of his jump is minus 890 is going to equal 890 divided by 9.81 times 16.7. Do a little algebra, throw things in your calculator. The force of his jump, which is how the force the ground is pushing up on him, which is also the force he is exerting on the ground, is going to be 2,357 newtons. And he is pushing the ground down while the ground is pushing him up.